All right, so due to the snow, so we're gonna conduct the exam review on Zoom today, and we basically gonna go over some of the exam review and and like the study guide, all of this. So before that, just let me know if you have any questions or any concern. Any question? Okay, so all right. So just let me take a look at the exam first, and then let me see how many questions we have. So remember that the third exam is going to be on Wednesday, and there are actually 15 questions. Okay, 15 questions. I'm gonna go over some of the similar questions, and then the exam should be 2 hours. Each question will be worth 5 points. There was some question was worth um more than the other questions. All right, so let me just share my screen real quick for that. All right, so this is exams one review. I would definitely post this videos on YouTube. You can watch it again. If you have any questions, any concern. All right, so I'm actually doing the Zoom meeting in the basement, so it might be a little bit like like some noises, some echo. All right, so I just want to let you know that the third exam is going to be 15 questions. Some question worth 5 points, some question worth 10 points. And so they have like a different distributions for that question. I mean, one question going to be one part of it, okay? And so it's on Wednesday. So 225, 225th. So I just want to make sure that you're gonna prepare good notes on it, and then I'm gonna emphasize the topics, the variety of topics, but I just literally let you know that, we should focus more on this and should focus more on that. And I have seen a lot of students still have trouble adding, subtracting the matrix, and multiplying the matrix. So before I started, I just want to let you know that I finished grading the first two homework. So the homework three is due on February 18. I know some of you just submitted, but if you can't submit it by tonight, that would be great. I know it's going to be very difficult, but I only have 13 students who submitted. The first homework got 19 of them. The second homework got 16. The third homework got only 13 students. So I don't want to take away 10% of your grade. I know this homework will be worth 20 points, which is doubling like the first two homework. So so that's very important. Um, if you have any questions, any concern, like learn how to solve these questions, just let me know. Okay. So when I start grading and when I finish it, so for those who submit it after I finish grading it, I would take away 10% of your grade. So make sure that you're gonna submit by tonight. I need to give out the grade before the third exam, which is very important. So you have something to review. And I know it's not going to be a lot of questions. I don't give out a lot of questions so we can look at the first homework. It's not going to be a lot of it. I would say. So it's only 10 different questions. I'm sorry, 6 questions, and then each of them has, like, so that one was kind of straightforward. You need to know how to find the inverse of the matrix. It's going to be a big grade on the third exam. Okay. All right. So let me just go over some of the similar question that we have on the third exam. Like I said, I would prefer you guys to figure out the some of the similar question like that. I would prefer you guys to focus on question number 5. So it says, well, I'm gonna give you like X and Y intercepts, right? It's pretty much the question that you can do it on your own. And then I want to find the lie equation. So we can simplify the slope by looking at the y2 minus y1 over x2 minus x1. So for this particular question, I just making sure that you know how to plug in those values, and then make sure you're not going to mess up with the x and y intercepts. And x2, y2, x1, y1 is literally up to you to set up those indexes. I would prefer the second part. You can take this one as y1. I'm saying this one's y2, so it will be a little bit better, so you can avoid some negative, but it doesn't matter which one. So let's say you take this as y2, you're going to take 0 minus 7 over. So when I take 0 minus 7, I have to take negative 6 minus 0. So that's going to give me uh, the ratio negative 7 over negative 6, which is 7 over 6. And then we can also use the y-intercepts, right? To b equal to 7, which is based on the y-intercept 0, 7, to find the equation. So apparently for this kind of question, you don't have to use the point slope intercept. I would prefer the student to use the slope intercept form. So this is what we have for B. So we can just rewrite the equation y equal to mx plus b. So we have the n was 7 over 6. X plus b. Are we good, guys? All right, thank you for your response, Janner. And you know, it's always better to see those points on the graph. I mean, you're not required to graph it. I mean, but it's very important that you basically visualize, hey, what a line looks like is passed through the x and y intercept, right? And then we can always verify that. So the y-intercept 0, 7, and then the x-intercept that we got was negative 6, 0. So I just want to make sure that my line must pass through these 2 points, right? Must pass through these x and y intercepts. So I just want to plug that in, y equal to 7 over 6, x plus 7, right? So apparently that is math, it must go through like those 2 points. So that works. And that's the correct answer for that, right? So I mean, it's better to testify the graph on decimal calculator to make sure that you lies correctly. But when it comes to the exam, you don't have to. You just simply look for the slope and then look for the y-intercepts, and that should be good enough the B was 7. I'm sorry. And if you can help me box the answers, that would be great. I appreciate it. All right. You should know how to solve like some of these questions, like but it's not require you just need to know about the line, for example, is costs and sell it for like $18 or something like that. So I would look at the question number 7. If I give you this question on the exam, it will be worth 10 points. So I just making sure that you guys are able to figure this out. So this is the little applications, and so the cost was based on uh the producing units, which is called X. And then it's a linear relationship. We can have y equal to mx plus b. And then if the cost was $1,300 to produce 20 unit and since 1750 to produce 35 unit, what is the fixed cost? So that's might be a little bit like problematic. So we need to know how to figure out the aim and also the B, right? So the question was simply giving us 2 points. So the X was the units and the Y going to be the cost, right? So the Y equal to mx plus b. I just want to let you know that you need to understand the question, how it looks like. So this is what we have for the cost. On the exam, if you see question number 3, it's have to be something like that, right? And then it's also give us the unit in terms of the X. And this is the units, right? So you got like given by 2 points. So all we have to do is just rewrite the equation and then we need to figure it out. So you're given by 2 points, 20, 1,300, and 35, 1750. So in this situation, we can simply look for the slope. Remember that we always have to find the slope on the exams, and we always have to apply the same rules, which is y2 minus y1 equal to x2 minus x1. So you can take 1750 minus 1300, and then we divide it by 35 minus 20. So we got the m equal to 30 again. So that's the problem, right? So that's the thing. And after that, what is the fixed cost? So the fixed cost going to be the B, and I want to figure that out. So in this situation, we need to rewrite the equation, which is y equal to mx plus b. So y equal to 30x plus b, right? The question asks us to solve for the fixed cost, which is b, and then we just plug in the points. Uh, x equal to 20, y equal to 1300, or we can plug in x equal to 35, y equal to 1750. That's perfectly fine. You should get the same answer. So the reason why I had to plug that in, you need to solve for the constant. So the 1300 equal to uh 30x. I just want to change the marker a little bit for x and y, just making sure that you plug in the values plus b. So we solve for that. So we're going to get 1300 equal to 600 plus b. So therefore, we can subtract 600 both sides. And we can have the b equal to 700. Okay. Are we good? All right. So, and then we need to understand the aims. So the slope means that the slope aim equal to 30. On the exam, I will ask you the question like what it means by the slope. It means that when x increase by 1, basically means that when we produce like one more unit, the cost is going to go up by $30, right? The manufacturer produce one more unit, the costs go up by 30, right? Dollars. All right, so this is what it means by the slope. I just want to make sure that we understand this and write the same thing on the exams. Okay, so it is just what we have so far. If the slope is positive, meaning that when x go up by 1, the y go up by a factor of the slope, where the slope is the ratio between the rise over run. So we should be able to translate that on the exams. Are we good? I just want to make sure that we got those indexes correctly. Let's say we have x equal to 20, the y 1300, and x equal to 35, the y equal to 1750. Well, the reason why I'm so sorry, um the graph that we need to do a little bit more so you can see those points. I know it's just like, yeah. And then the line that we found have to pass through these 2 points. So let me just plug in the line, which is y equal to 30x plus 700. So apparently the line must pass through those 2 points and has a fixed cost, which is 700, meaning that if we produce no unit, that still cost us $700, right? If you don't produce anything, it just like stay there. So you might have to pay for rent, for electricity, and all of this, right? So that's the problem. All right. So this equilibrium state represents the lie equations, and we can also figure it out by setting up the slope and the y-intercept. On the exam, I will ask you to interpret the meaning of the slope, right? So the slope equal to 30, meaning that when we produce one more unit and it's gonna cost us $30, right? So a coin, when you sell it, you have to be like much more than what we produce. All right. And then the next thing that we'd like to emphasize was the perpendicular. So this is going to be like a trick question. You have to be extremely careful when it comes to the exam. Um, so perpendicular means that so two lines have a negative reciprocal slope. Okay, so for example, if we have the slope equal to m equal to if one line was the slope m1 equal to, let's say, like 2/3, for example. So the perpendicular line have the slope m2, they have to be -3/2, right? So we're gonna flip the fraction and divide it by two, and then flip the fraction. I'm gonna change the sign for that. So we have the slope equal to this is this is gonna be like a trick question. It's not that trick if you understand the concept, it should be well. So if you have the slope equal to like 1/4, right? So the perpendicular line, we have the slope equal to -4. So vice versa, if you have the fraction 1/4, the perpendicular line had to be -4/1. So just chain aside for that. Make sure you're going to chain from positive to negative, and then you just have the flip fraction. However, if, for example, we have the line y equal to 5, for example, we have the slope equal to 0. Okay, so because the m equal to 0, we're going to get y equal to mx plus b. Then the perpendicular line will have x equal to something, right? Uh, is x equal to, let's say x equal to 4. So apparently that the slope going to be undefined in this case. I just want to give you like a heads up, like for what's going to happen on the exam. So let's say we have the line y equal to 4, y equal to 5. Okay. So let's say this line was passed through the let's say like a -2 and 5, for example. So this point, and then I need to find the perpendicular line that passed through this point as well. So the line have to be x equal to -2. So because it just corresponds to the x values, and this should be parallel to the y-axis. So which is why we're going to get the x equal to -2. The y is going to be fixed. The y equal to 5, right? Most of the times. I'm sorry, x equal to -2. I'm so sorry. The y is any value. So it is what going to happen on the exam. So it might be a very simple questions. I give you the point, and then it have to pass through the point and perpendicular to the line. So you can just figure it out by looking at the x-axis, the x-index, or the y-indexes accordingly. All right. You're not required to find any intersection points, but you need to figure out what is the next row operations to solve for the matrix system. So let's say we look at question number 13. So this is going to be like one of the questions going to be on a test. I can tell you which one. You just have to perform one next steps, right? So just only one, you just take like one step. I know some of you might be solving the entire parcel, the entire matrix, but you're not required to do this. So I will give you a 3 by 3 matrix, but requires 1 or 2 steps. So make sure we're not going to spend like 40 minutes just simply solve the entire matrix system. So just making sure when it comes to the exam, you have to highlight a keyword, perform the next elementary row operations. So that means that we're not going to solve the entire matrix, but we're going to like perform 1 more steps, 1 or 2 steps. In this case, it's only 1 steps, and put the matrix in diagonal form. So that I just want to remind you that what we learned about a matrix, make that equal to zero. We have to make that equal to zero, make that equal to zero, and make that equal to one, and then make that equal to zero, make that equal to one, make that equal to zero, make that equal to zero. So it just have to go like this, right? For most of the matrix system, regardless of the dimensions. So it can be like 5 by 5 matrix, it can be like 10 by 10 matrix. All we have to do is just making sure you're gonna make the first index of the matrix equal to 1. And then after that, for the entire column, we're gonna make that equal to 0 and 0, that's good. That's perfectly satisfied the questions. So now, and then after that, we're gonna look at the last row of the matrix. You're gonna make that equal to 0, so whatever it is, and this one had to be equal to 1. So for that example, that we need to make -5 equal to 0, right? You need to make sure that make -5 equal to 0. So you have to perform the row operation, right? So the reason why we have to make all of these equal to 0 when you multiply by like a certain coefficients and we add them up the matrix, it doesn't change the index of the first. It doesn't change the first index of that row, which is why this is the requirement to make sure that all of these equal to 0. So for that scenario, I want you to change the row number 3. So you have to write R3 first. Unless that you want to change, like unless that you have to multiply by a certain value, by a certain ratio. So the R3 always stay the same as R3, so it doesn't really change it, right? So now we need to multiply the R2 by 5. So the reason why I have to multiply R2 by 5 is I want to make that 1 equal to 5. So 5 plus -5 equal to 0. So we're going to plus 5R2. So remember that we can only use the second row to simplify the third row because, like I said, we cannot use the first row. For example, we're going to change in there for the first index of the third row. That's not going to be helpful. The whole point of making all of these two equal to 0 because we need to take the second row, we need to multiply by certain coefficients. We add up to the third row. But like I said, since we're going to change the value on the third row, you have to write R3 first. So when you multiply the R2 by 5, remember that the first row still remain the same. Like the first and the second row are not going to be changed. So you just rewrite 1, 0, 3, and then 9 on the other side. And then on the other hand, we're going to have something like 0, 1, -3, and then 2 on the other side as well. So technically that we don't really make change on the first and the second row, we just only make change in the third row. So remember that the index changes must appear on the third row, which is why I put R3 first. So now I just want to make sure that we knew how to do the map correctly. I just want to rewrite the the third row, which is -5, 0, -5, 4, and 1. And then now you multiply the second row by 5. I mean, you can just do it in your head, but I just want to do it like rewrite them, just making sure we get it right. So we multiply um the second row by 5, so that 5 times 1 is 5. 5 times -3 is -15. You can't do it in your head and then just add up to the third row. And then 5 times 2 is 10. And then we're going to add them up. I just want to let you know that we don't really have to like perform this math work on the question, because this question is going to be only 5 point. So now when you add them up, it should end up with the new combination that we have for the third row. So we're going to get 0. And then, so -5 plus 5 is 0. And then we're going to have 4 minus 15. 4 minus 15 will be -11. And then we have 1 plus 10 equal to 11. Okay, any question? And of course, the next step that we have to divide it by -11 to make that equal to 1, but you don't have to. Are we good? Any question? Yeah. Is that good, people? Any question that you don't understand, please ask me now, because we don't have much time left until on Wednesday. So you can also check the answers on this. I'm gonna answer key, so that should work. Remember that we only perform one step to solve the matrix, but not the entire matrix, but just like one steps. The same thing that happened to this problem after you make that equal to 0, to make that equal to 0, make that equal to 1, then you need to make sure that this one have to be equal to 0, right? This one 0, this one 1, 0, 0. And then we're gonna finish it, right? So we're gonna make that equal to 0, so that's the required. So you're gonna make -2 equal to 0. So like I said, that we need to perform the raw operation. So that we can't use the first row to simplify that. The question is going to be requires us to use the third rows, because this is what we have for the corresponding index. So I want to make change on the second row. We have to go for the second row first, R2, right? So we notice the coefficient for the second row is -2, and then we need third row to be 2. So we add them up, we're going to get 0. So we're going to add plus 2R3. So making sure when you make change on the second row, that index must go first, right? So R2 have to go first. I want to make change on the third row, so I have to take R3 first, plus 5R2. So like I said, that we're not going to actually make changes on these two. So I'm going to rewrite all of this, right? The first and the third rows remain the same values. So the honor row that we're going to make change, like I said, it's have to be on the second row. And then, like I said, that we need to multiply the third row by 2, so 0. R2 plus 0, so 0 was 0, 0. And then the same thing for that. You multiply the third row by 2, so 0 times 2 is 0, 1 plus 0 is stupid 1. So for the third index, we need to take R2, 2R2, which is 1 times 2 is 2, negative 2 plus 2 is 0. Yeah, so the reason why you have to multiply by 2 coefficients. For the third row, we want to make sure this one has to be equal to 0. And now we need to care about the last one. So R2 was 2R2 was 2, 2 times 1 was 2, negative 2 plus 2 also 0. Are we good? Any steps of the question that you don't understand, please let me know. Are we good with that, people? Yeah. Okay. All right. Hello. Am I edible? Guys?
We could hear you.
Okay. Thank you for that. Okay, so if I'm audible is good. I'm so sorry about that. Just a little. All right, go upstairs. Go upstairs. Okay. All right, guys. So now the next step, like I said, we need to perform this row operation. We need to perform the row operation for that, and then, but we need to do like 2 steps instead of 1 step because it's going to make change on the second row and the third row, right? So now we observe the row operation up here changes the row values. Up here, some changes on both R2 and R3. So we have to apply like 2 row operations for that particular question. So like I said, that the question we observed was like make changes on 0 and 0, which is the required for the question, right? So that makes sense. So in this case, we use R1, right, to make changes on both R2 and R3. All right, so for this particular question, though, we have to use R1. But when you write, we have to write R2 first. And then we need to multiply the first row by -4. So we have to minus 4R1s, right? So the reason why I need to multiply the first row by -4, so -4 plus 4 equal to 0. On the other hand, for R3, so like I said, we need to make changes in R3 using R1. So the R1 was 1, the R3 was -4. We just simply multiply the first row by 4. So we're going to 4 plus -4 is 0. So now essentially that matrix becomes, let me just rewrite them. Well, the first rows remain the same indexes, like 1, 7, 4. And then we have -5. So now we just simply have to make change on the second rows and third rows. So the first one have to be 0 because, like I said, that we need to take um, the first row we multiply by -4, so -4 plus 4 is 0. And then we do the same thing for -4 times 7 is -28 plus 1 on the second row. So -28 plus 1 is -27. And then the same thing for that we need to multiply the first row by -4. So -4 times 4 is 16. -16. -4 times 4, -16. I'm sorry. I'm so sorry. You're gonna get -9 minus 4 times 4. So -9 minus 4 times 4 is -25. And then we do the same thing for that. I'm gonna take R2, which is 9 minus 4 times -5. So minus 4 times -5 is 9 plus 20 is 29. We do the same thing for the last row that we're gonna take R3 plus 4 R1s, right? So we take R3 was -4 plus 4 times 1, which is -4 plus 4 is 0. And then we do the same thing for that. We're going to take R3 was -3 plus 4 uh, times 7. So -3 plus 4 times 7, which is -3 plus 28. So -3 plus 28 was 25. Similarly, then we're going to take R3, which is 5 plus 4 times R1. So 5 plus 4 times 4, which is 5 plus 16. So 5 plus 16 is 21. Finally, then we're going to get 0. 0 plus 4 times R1, which is 4 times -5. So 0 minus plus 4 times -5 is -20. So that's the answers for that, and we can also look it up on the answer key for question number 15. That we should be able to get the same thing. You can also like do it one by one, so you can just simply taking care of the R2 first, and then we can take care of the R3 later. Or you can do, like either way. You can combine them. So when I combine them, I have to make sure that, well, all of these indexes are, like perfectly matched from um what we have for the questions, and making sure when you can, do the math correctly. So let's say R2 minus 4 1. We have to take R2 going first, like 4 minus 4 times 1 is 0. 1 minus 4 times 7 is -27. -9 minus 4 times 4, which is -9, minus 16 is -25. 9 minus 4 times -5, which is 4 plus 20 is 29. So yeah, the same thing for that. We do R3 -4 plus 4 1, so which is 0. -3 plus 4 times 7 is -3 plus 20 was 25. And then we have 5 plus 4 times 4 is 21, and 0 plus 4 times -5 is -20. Okay, so remember that we don't necessarily have to perform like all the steps, or we just have to figure out what is the next step for the Gaussian method. We should also be able to do question number 19, for example. I can't simply skip. So you might see something like that on the exam. So don't be surprised if you see like the similar question. So this matrix and that matrix basically identical because when the last row was 0, so we can simply ignore it. So for this particular questions, let's say the third row is missing. So the x, y, and z, the first row is going to be x, the second row is y, third row is z, right? X, Y, Z. And when you read it up, like x, y, z, right? And then, so in this case, so they have an infinite many solution, infinitely many solution, or infinite solutions. And then we need to like solve for that, right? The solutions, so this we have infinite many solution. The z is the free agent, so it can be any values. And then the x equal to 4. X was based on this, right? X was, we look at that. Look, x equal to 4, okay? So now we need to rewrite the second part, which is y plus z equal to 3, and then we can solve for y. We subtract z both sides, so we can have the y equal to 3 minus z. So remember, x is a fixed value, and y is a dependent variable. It depends on the z. The z can be any values it takes, so you can have infinitely many solutions. On the second part, so we observe that the first 3 index was 0, but the last one is not equal to 0. If the last one was all 0, that's good. We're good to go. But since the last one is not equal to 0, of the third row is not equal to 0. So meaning that there's no satisfy x, y, z that, like it can't literally take like 0x plus 0y plus 0z equal to 2. So for that particular question can say there's no solution. And then the last one that we can literally check, x, y, and z, they have a unique solution. So in this case, you just rewrite x, y, z, which is 7, 12, and 10. Right? It's basically very straightforward on the exam. I can give you those questions like that. And if you see this question on the test, that should be about like 10 points. So x was 7, y was 12, and z was 10. Are we good? All right. You might also be asked to combine, like add or subtract the matrices in the situation that we need to do, perform the matrix operation. So in this case, when you add and subtracts, you have to make sure that the matrix must have like the same dimensions. Okay, so for this particular question, you can literally check that we can just combine them. So we just add them up. So you're gonna take 9 minus 5 is 4, -2 minus 8 plus -8 was -10, -7 plus 2 was -5, 2 minus 7 is -5, 8 plus 4 is 12, -7 minus 2 is -9. All right, so we do the same thing for part B, which is simply, so they do have a same dimension. So -1 minus -1 is -1 plus 1 is 0. make sure that you take care of the size correctly. So minus minus plus, and then 0 minus 3 is -3. 3 minus 3 is 0, and 1 minus 1 is 0. So that's a little bit tricky. You have to subtract the matrix. So make sure we're gonna subtract the value. So that one was kind of like different because 2 going to be the scalar. So meaning that it's better to rewrite the matrix. We have to multiply by 2 first before we can combine them. So in this situation, you get -3, 1, and then the bottom was 2 and 5. And then I need to add the matrix that multiply by 2. So you're going to get 2 plus 6 was 12. And then 2 times 2 was 4. 2 times 4 was 8. And 2 times 2 is 4. So like I said, when we multiply by the scalars, we have to multiply by every single index. I just want to let you know that we got this part correctly, because when it comes to the exams, you will be asked to add and subtract the matrix with a scalar. So we have to be extremely careful. So -3 plus 12 was 9, 1 plus 4 was 5, and then 2 plus 8 was 10, 5 plus 4 was 9. All right, just a little bit more that we should know is when multiplying the matrix, a scalar with the matrix. So make sure we have to multiply for every single index, right, of the matrix. A scalar to every index of the matrix. So this is good to know, and don't just only multiply by a single number or a single row. You have to multiply by every single thing. All right, so there might be some matrix that are not addable, are not subtractable, are not multiplicable. So it depends on the dimension of that. For multiplication, you have to be extremely careful. So let's talk about like some of these questions. And so you basically going to have a better understanding what it is. So for the first matrix, you need to check for the dimension. For the first matrix, so the first one has dimension 3 by 1, right? So the 3 row and 1 column. And then you multiply with the matrix, which is 1 by 3. Okay, so that'll be 1 row and 3 column. I know that some of you just like, well, make mistakes on it. I just want to let you know, that's very important that we do that. So just want to give you a little bit like, so this is like 3 rows. So row have to go first and 1 column. And then, so this means that we're going to get 1 row and 3 columns. Okay. So those are very important that we should know. And then remember that the rows, the column of the first matrix and the row of a second matrix are going to be get canceled. So the column and the row will be get canceled in this case. So this one going to be disappear. And then the resulting matrix, like I said, it have to be 3 by 3 matrix. So when you multiply, you have to be extremely careful. So the resulting matrix can be just some combine them. So 1 times 4 is 4. And then 1 times 0 is 0. 1 times 3, 3. 2 times 4 is 8. 2 times 0 is 0. 2 times 3 is 6. -5 times 4 is -20. I don't think I have enough space. and then -5 times 0 is 0, and um, -5 times 3 is -15. That's it. So let's say I need to take the first row times the first column, the index has to be in the 1, 1. The first row times the second column, the index has to be 1, 2. The first row times the third column, the index has to be 1, 3. The second row times the first column, the index has to be 2, 1. The second row times the second column, the index has to be 2, 2. The second row times the third column, the index has to be 2, 3. The third row times the first column, the index has to be 3, 1. The third row times the second column will be 3, 2. And then the third row times the third column has to be like 3, 3. So you have to keep that in mind. They have to be like on the like appropriate positions of those indexes, and you should know what the resulting matrix looks like. It's cancel out the row of upside the column of first matrix and the row of the second matrix. So we do the same thing for that. So this one is 2 by 2 and 2 by 2. Then we got 2 row and 2 column. And then we multiply with 2 row and 2 column. That's perfectly good that we have. So for this combining matrix that we can have was also 2 by 2 matrix. So we're going to take -2 times -2 plus 3 times -1. You're going to take this times this and we have to take the first row times the first column. I know some of you might get like a lot of trouble doing this. So we're going to multiply with the corresponding indexes, -2 times 2, -3 times -1. We do the same thing for that. We're going to take -2 times 0 plus 3 times 1. And then I'm going to get this one is 3 times -2 plus 2 times -1. And the last one we got was 3 times 0 plus 2 times 1. And then, so the resulting matrix that we had was, also 2 by 2 matrix. We got 4 minus 3 is 1. And then 0 plus 3 is 3. -6 minus 2 is -8. And 0 plus 2 is just 2. Are we good? So those are very basic indexes. Now the last example was kind of tricky. So we're gonna get 2 by 3, and then you multiply with 2 by 2 matrix. So now there's no way that you can take the first row times the first columns because we don't have enough index for that. So remember, if the column of the first matrix and doesn't match with the row of the second matrix, so meaning that this matrix is not multiplicable, right? Its columns of the first matrix does not match the row of the second matrix. So we just simply say undefined. Okay, so we cannot combine the dimension of the resulting matrix. So, any question? All right, guys. So if you have any question, just please ask. There will be questions. Uh, we can multiply two matrices that have like uh, the column of the first matrix does not equal to the row of the first matrix, so we can't multiply them because you can look at um, the first row, we're going to get 3 index because we have 3 columns. And the second matrix is only have 2 index because I only have like 2 rows. So the first one, you got 3 columns. The second one, you got 2 rows. We can't multiply them, right? Is that clear from what we're doing so far? Any questions? And any question, any concern? All right, guys. So we definitely do the same thing. Like we need to prove AB is not equal to BA. So those are very important concepts. So I'm gonna have this one's like, so 1, 4, 2, 3. And then you multiply with like B. Just let me rewrite AB first. So the matrix B that we had was 1, 2, 3, 1, 2, 4, 3, something like that. So apparently that we need to take the row of the first matrix times the column of second matrix. So you can just get the indexes, you can just do the math. So 1 times 1 is 1, plus 4 times 4 is 17. And then 1 times 2 was 2, plus 4 times 3 was 12. So 2 plus 12 was 14. 1 times 2 times 1 is 2, plus 3 times 4, which is 12. So 2 plus 12 is 14. 2 times 2 is 4, plus 3 times 3 is 9. 4 plus 9 was 13, right? So now we just have to compute B8. And all we have to do is just say, well, they're not equal to each other. Apparently 100%. So we're going to go like 1, 2, 4, 3. This, despite the fact that they have the same dimensions of like, because they are the square matrix times the square matrix. So we should add it up with the square matrix as well. But like I said, that we're simply not going to get the same results. So this is 1, 4, and 2, 3. So apparently that we're going to have the resulting matrix. We're going to do the first row times the first column again. So we're going to take 1 times 1 was 1, plus 2 times 2 was 4. 1 plus 4 is 5. 1 times 4 was 4, plus 2 times 3 is 6. So 4 plus 6 is 10. 4 times 1 is 4, plus 3 times 2 is 6. So 4 plus 6 is 10. And then the last one was 4 times 4 is 16, plus 3 times 3 is 9. So 16 plus 9, 25. All right, so apparently that AB is not equal to BA. That's uh that's that's what it is, because they're not inverse matrix. Okay, only the inverse matrices gonna be equal to each other, and that equal to identical matrix 1. All right, this is what it is. Any question, any concern? All right, and then we need to do some of these questions. The matrix, you're gonna see this question on the exam is gonna be 5 points. has no inverses, right? Has no inverse. When X is so the matrix, the square matrix has no inverse if and only if the determinant equal to 0. All right, so the determinant would be AD minus BC. So we can take 3 times 36 minus 4 times X equals 0. And then you're gonna combine them. So the determinant would be 3 times 36 is 108 minus 4x. So when you set the determinant equal to 0, meaning that we have no inverses. So therefore, d equal to 0, or we have 108 minus 4x equal to 0. So we subtract 108 both sides. And then we divide both sides by -4. We can solve this equation whatever the way you want to. So we got this one -4x equal to -108. And then we divide both sides by -4. So we solve for that. We got x equal to 27. Okay. So you will be asked to find the inverse of these matrix. So the first we need to find the determinants for the matrix. So the D is going to be 1 times 4, AD minus BC, and then 3 times 2, 2 times 3. So in this case, it's going to be 4 minus 6. You got this one is -2. And then the inverse matrix is A minus 1. So that'll be 1 over D, right? I just want to let you know if A was I don't have enough space for this. So if A was um, A, B, C, D, for example, so therefore, then the determinant going to be AD minus BC. So therefore, we have the A inverse. So all we have to do is just simply swap the A and D. So that become dA. And we're going to change the side for B and C as well. So that become -B and -C. Are we good? So we can simplify the inverse of the matrix. So we have to take 1 over, I'm so sorry, we have to multiply with 1 over D first. We have to multiply with 1 over D. All right, so all we have to do is just do like 1 over -2. And then I'm going to rewrite the terms Instead of 1, 2, 3, 4, you're going to get 4 and 1. You're going to swap 4 and 1 in this case. And chain the cipher B and C, so that become -2 and -3. And then we have to multiply with -1/2. So we're going to get 4 over -2 is 4 over -2, just -2. -2 over -2, just 1. -3 over 2 is 3 over 2 is 1.5. And 1 over -2 is just -1/2. So in this part B, it doesn't have an invert because of D equal to 0. So no inverse. So why the D equal to 0? So we can just simply take 3 times 0 minus 1 times 0, which is 0. So has no inverse. The same thing for that, we can do D equal to -1 times 7 minus -3 times 2 times -3. So we're going to get -7 plus 6, just -1. So you can also find the inverse. So just simply 1 over D, just -1 over 1. I'm sorry, just 1 over -1, so just -1. And then we just simply change the signs for that. We just swap the index for 7 and 1. 7 and -1s, and then we're gonna change the cipher B and C, so it become -2 and 3. Now you have to multiply by -1 in this case. And then we just simply change the sign again. So that's become -7, 2, -3, and 1. Are we good? Any question? All right. So if there's no question, let me move on to the next examples, and then um, so you will be asked to use the Gaussian method to solve some of the equation. And then after this, I will let you go. Yeah, we pretty much finished it. Like, we need to know how to find the inverse of the matrix. We need to know how to multiply the matrix. We need to know how to subtract the matrix. How to combine a matrix and write a matrix in the system. All right, guys. So we need to write the matrix and write the equation in the matrix system. So we're gonna have like 5, 1, 6, 3. And then 12 and 9. Okay. So this is ax equal to b. So we need to solve for the system by, you know, you can divide the entire equation by 5 and can use the second row, we subtract them. And then you divide it by -1, you can just swap them, right? So on and so forth. All right, so first thing I have to do, I'm gonna swap R1 and R2. The reason why I swap because I'm going to take the first row, subtract the second row, so I can just get that equal to 1. We observe this 5 and 6, right? 6 and 5. I swap them, then I'm gonna take R1 minus R2, right? I mean, you can subtract like R2, R1 minus R2, you're gonna get -1, something like that. You're gonna divide it by, by -1. That's perfectly fine. We have more than one way of solving the equation. So the first row will be changed. So 6 minus 5, 1. 3 minus 1 is 2. 9 minus 12 is -3. And then I'm going to rewrite the second matrix, which is 5, 1, and 12. And then after that, I'm going to make that equal to 0. Right, make 5 equal to 0. So, so the way that we're going to do it, just simply, we use the first matrix, right? You're going to take R2. You have to write R2 first. You want to make change on those indexes. Minus 5 R1s. Like I said, we need to multiply the first row by -5. I'm going to keep 1, 2, and -3. So remember that the first row we made and change, we need to change the second row. So we multiply R1 by 5. So we're going to take 5 minus 5 times 1 is 0. We do the same thing. 1 minus 5 times 2. So 1 minus 5 times 2 is 1 minus 10 is -9. 12 minus 5 times -3, which is 12 plus 15. 12 plus 15 was 12 plus 15 is 27. All right. So now the next step we have to do, we're going to divide R2 by -9. Make sure you're going to make that equal to 1. Not 0. So when you make that equal to 0, then we have to use another row to subtract. But when you make that equal to 1, you just have to divide it. In this situation, we just have to divide R2 by -9. So you're going to get 1, 2, and 3 again. 1, 2, and -3. And then the second row is 0 divided by -9. You're going to get 1 and -3. -9 over -9 ones. 27 over -9 is -3. Okay. And then finally that we're going to take, we need to make 2 equal to 0. So we're going to take, make 2 equal to 0. We're going to use R1. We use R2 minus 2R1 again. So you have to multiply the second row by -2. Add them, we're going to get 0 for sure. So remember that the second row was finished. So remember that we're not going to make change on the second row. So we want to make change on the first row. We have to write R1 first. So now we're going to take R1s, which is 1, like -2 times 0 just still be 1. Remember that this one is 0, is the first one, the first index not going to have any effects. And then, so -2 minus 2 times 1 is 2 minus 2 is 0, of course. And the third one will be in -3s, minus 2 times -3, which is -3, plus 6 is 3. So therefore, we finish that after we get to the diagonal matrix. Then the solution is xy will be 3 and -3. So x is right here. The y is going to be on the second. All right, so one more question. So I will let you go quickly. You might be asked to use the inverse matrix. So use the inverse matrix to solve the system. So for example, we have ax equal to b. So we can solve for x equal to a minus 1 times b, which is take an inverse times b, right? So that's one is pretty obvious. So the inverse matrix will be given. Just use the inverse a minus 1 and multiply with b. That's it. For example, we have like some question like this. All right, so I'm gonna give you that equation. So hold on, the inverse must be given, so we have to find inverse for the matrix. 1, 3, 1. So hold on a second. I don't have a question on my notes. 1, 3, 1, 1, 3, 2, 7. So I need to find an inverse. Making sure I get it right. So we have 7, 1, -3, and -2. That's good. So A minus 1 was given. Which is 7, -3, -2, and 1, right? So this should be given, right? It's given. And then we also have the B was 1 and 1. So now I can just solve for X. It's just simply A minus 1 times B. We just take the inverse. The inverse was given. And then just multiply with B. And then we just multiply these two matrices. Just making sure I got it right. Just making sure. And times B. So now the resulting matrix, you're gonna take, it have to be 1 and 2. Right? You're gonna take 7 times 1 is 7, minus 3 is 4, and then -2 times 1 was -2, plus 1, so -2 plus 1 is -1. That's it. So the x has the value which is 4 and -1, so we can just plug that in. X, the 4 minus plus 3 times -1 is 1. That's correct. 4 times 2 is 8, plus 7 times -1 is 8 minus 7, that's 1. That's correct. So this has to be the solution. Okay, so if the question gives us an inverse, all we have to do is just multiply with b, and then you're gonna get x. You just solve for x quickly. We just have to multiply two matrix. All right, any other question that you might have? Guys, so you have any question? We have the exams on Wednesday, so making sure if you have question, please ask. All right, so since there's no questions, let me take attendance. I will see you on Wednesday. All right, guys, so stay warm, stay safe. If you have more questions, just send me an email. I will be more than happy to help you out with that, okay? I will definitely post the videos on YouTube. You can watch it again if you need to. Also post the notes under content. You can see exactly what you have over here. All right. So I'll see you guys on Wednesday. It should be in person that we're gonna take the exam. Make sure you're gonna prepare like 1 page of notes. Just go over all of these questions should be fine, except question number perpendicular. So I might give you like two questions. Let's say y equal to 5. What is the perpendicular line? Have to be x equal to 4, for example. All right, guys. So have a wonderful day. Take care.
Thank you, Professor. Have a nice day.
Thank you. Thank you.